Today we're looking at the distance formula, and we're going to look at it on a coordinate grid with something that we know, and then we're going to actually use the distance formula. So the distance formula is the square root, and then underneath the square root, it's x2 minus x1. Oops, should be a little one. And that whole quantity squared plus y2 minus y1 and that quantity squared. And then when we have a points, so we have 2 points. We have an x1, y1 point, and we have an x2, y2 point. And so we'll go through how all that works. The first thing we're going to start is with graphing it. So if I graph those 2 points, remember when we graph, this is our x coordinate, and so it's the horizontal, and y is our vertical. So I'm going to do -3, -2, and I'm just putting in one dot where those two pieces meet. And then I'm going to put in 5, 4. So to the right 5 and up 4. And when it's on that grid and my numbers are small enough, I can actually look at this and look at it as a right triangle and see how far over and down, and I could have my right triangle go the other direction. My ultimate goal is to figure out this length here, which is C. So I can count up my legs. 1, 2, 3, 4, 5. This has a length of 6. 1, 2, 3, 4, 5, 6, 7, 8. And then I can use Pythagorean theorem. And Pythagorean theorem would say that 8 squared plus 6 squared, because I have the 2 legs and I'm looking for the hypotenuse. So 64 plus 36, which is equal to the square root of 100, or 10. So that works, and there's no reason why we can't use it, especially if our numbers are small enough. A lot of times our points are going to be bigger than what we want on a grid, or be using other pieces. Our formula becomes pretty easy, and I'm not asking you to memorize it. You just kind of need to know how to use it. So my first point, I'm going to label x1, y1, and my second point is x2, y2. And now what I'm really doing is replacing everything at time I see x2 in my formula, which is this one here. I'm just going to substitute in the number that it is. And in general, that's all formulas are, is I'm just going to substitute in the numbers that I know. So the things that stay, the square root's going to stay. This first parenthesis stays, a minus, a squared, a plus. So this is like our basic piece. And now I'm just going to be plugging in my 4 numbers. So the first number up here says x2, and I look at my points, x2 is 5. The second number says x1, and my second number is a -3. So I kept my minus, and then I know that that's going to end up being a plus. Looking at the next part of the formula, it says a y2, and y2 is 4, and then y1 is a -2. So now I'm just going to take care of what's in the parentheses. My square root, I'm not dealing with that yet. So I get 8 squared plus 6 squared. All that distance formula is really doing is telling me the lengths of my legs. That's my goal for that distance formula. So now I'm at the same spot I was before. So square root of 100 equals 10. It might seem like more work at first, but it will become easier as we're working with it. So the distance formula is similar to the Pythagorean theorem because it's the distance formula finds the lengths of the legs. Oops, I need to say distance formula finds the length of the legs. And then that's Pythagorean theorem. We haven't had the slope formula yet. We're just doing things in a slightly different order. And so don't worry about that one. You'll see it in next semester. So we're going to use the distance formula because I want you to practice something that you don't know. So I'm going to write the distance formula on the top of this paper here. x2 minus x1. Remember the little ones and the little 2's are really just to tell us from the different points so that I know where I'm taking my information from. So when I'm looking at my first point, I'm going to label my x1, y1, x2, y2 just to kind of help myself out a little bit. So it's going to say -1 minus -2. Oops, those are my y's. That's fine. We'll just put the rest of it on in front of it. And then our x2 is -5 minus 0. I don't know if I can move this without stealing other parts. I want to make that look a little more normal. Okay, now it looks better. So now I'm going to simplify within each parenthesis. It's a -5. I'm going to keep that in parentheses because I need it to be -5 squared. As long as you know that that answer is going to be positive, we don't have to worry about the negative. We should keep it when we write it, but when we type it in the calculator, we don't need to worry about that. The other one's going to end up being a 1 squared. I don't need a parenthesis there because I don't have to deal with that negative piece. And so then I should get 25 plus 1. The lengths of my legs are always going to be positive, so that will help with remembering what we're looking for in terms of whatever we're squaring. We should not ever have a negative number because I can't have a negative length of a leg of a right triangle. And then I take the square root and I end up with 5.1. So a lot of it is just that substitution piece, making sure I'm putting the right pieces. Again, x1, y1, x2, y2. And I'm taking the pieces that I know and substituting them into the equation. It's a great point right now to try to pause and see if you can set it up correctly, and then I'll go through it. So I know it's the square root. My x2 is -5, and my x1 is 6, so it's -5 minus 6 squared. I don't want to add in extra negatives. There's always a minus between the two. So looking at the next one, this is the stuff I know, and now I'm just going to plop in my y values. So y2 goes first, and y1 is second. And now I simplify within each parentheses. So -5 minus 6 is -11. Since it's a negative, I'm going to keep it in parentheses. Plus a -5 squared. -11 squared is -11 times -11, which is 121. If I did 11 squared, I would still get 121. -5 squared is -5 times -5. So negative times a negative will always be a positive. So 121 plus 25. And then I take the square root. So that's the square root of 146. And that is about 12.1. So you just have a couple more of those to be working with. And then seeing if you can come up with some of those. There's a few different points that you could possibly come up with.